Hi there, today we're taking a look at a slightly bigger machine. This is the Dragon 32 and it was a Welsh-made computer from around 1982-83 and it's really nice mechanically. It's a very strong plastic box, a very big one as well, and it has a really nice keyboard. If we look at the back, we have here power supply through a B9 connector, which I find really weird. Then there's an on-off switch and a plug for a computer monitor. This is a DIN 5 switch and I guess it's RGB. I have a cable for this actually, but the output of that is a composite sync, so I'm not too sure, but maybe when we open it up we have some idea. On the left side of the computer here, there we go, if you can see that. We have on the left the TV out. We have a reset button, a joystick input, two joysticks actually, and as far as I know these are analog. So they were kind of unique for that period, where most joysticks were just a switch. When you move the joystick around, it will just open and close some switches. In the middle there's a tape interface, and on the left here, sorry, for you on the right, there is a I/O connector for various controls. And I think that's about it. On the front there's nothing. And then we have on the right here, there's a cartridge connector for, I guess, plugging in games or for other things. It's basically for a PCB edge connector down here. And on the back, this is hard to focus, I guess. On the back we have a sticker here, Dragon Data Limited in Port Talbot. So yeah, it was really Welsh, and my serial number is 79,772. So yeah, pretty nice, and the patents have been applied for, so whoa, thumbs up for that. So yeah, okay, let's take it apart and see what's inside. I hope we can fit it in front of my camera. And this one has a massive PCB. Let's just remove the keyboard, and we can take a better look. Using little metal brackets for that. Very nice mechanically. Not all this ribbon cable junk. Okay, so we're in, and let's see what we got. Obviously, on the back here we have a massive power supply, and this is single-sided PCB. And we have a TV modulator, which is an Aztec UM1287. This is the one with video and audio. So if you have a TV with audio using the UK PAL standard, which I don't, then you can hear audio through your TV monitor. There's a little trimmer here for the video signal to get this stabilized, and with a little budge resistor. But anyway, that's pretty cool. On the power supply, which obviously have to supply AC, we have a lot of diodes, big ones for the diode bridge, and we have an LM309, which is a voltage regulator, and another two regulators here. One is a LM340T, and the other one is a LM7905. And the 7905 looks a little bit bent. And there's a screw hole here for mounting it on the heatsink. But I think they're not going to do that because the casing on this chip is not on the same potential as this one. I don't think this one is ground, if my memory serves me correctly, for the 7905. Now this layout of course also explains why all the connectors are on the side here and not on the back, because the main PCB is actually not aligned with the back of the casing here. This PCB is Mark II, and the chips have a date code from early 83, like week 9 of 83, week 3 of 83. So guess this machine is early 83. What we have, apart from the power supply, is of course the main CPU, which is Motorola 6809. And that is a fairly unusual choice for a CPU, but okay, no problem. Next to that we have the ROM for the basic interpreter. And in the middle here we have a really important chip, which is 74LS783. This is a Motorola device, and it's basically identical to the 6883. And that is a synchronous address multiplexer. Basically what it does is provide glue logic between the CPU and this chip out here, which is 6847, which is for video generation. And it also handles the memory for dynamic RAM. So this is the poor man's version of the ULA. It basically does the same thing as a ULA, but it's not a custom chip. It's something that Motorola designed together with the 6809 for system integrators like Dragon. So yeah, it's fairly straightforward design. This thing handles address decoding and memory and accessing the video. And the name synchronous address multiplexer basically means that the video generation chip can access RAM at the same time as the CPU can access RAM. So the CPU is running at full speed, and while the CPU is doing some internal processing, this little video chip down here, the video generator chip, can access the main memory. So it's pretty good design. We can handle everything simultaneously. Something interesting is of course all these OK stickers, and I don't think they are added by Dragon Data, although they might be. I think it says 04 here, but I'm not quite sure. But anyway, you can see someone has stuck in a pin down here on the ground, so that they could put an oscilloscope probe or something together. And I'm not sure whether I should pull it out. I should. And I hope there's still contact down in the IC socket now. Hope it wasn't put in there just to get a better contact. But anyway, we have another two chips here, and they are both 6821, and they handle all the parallel I/O. Like for instance to the keyboard here, and also to the parallel I/O connector. The signals to this expansion connector goes through 74LS244, which is an output buffer, so we can send signals that way in. And I think there are some ways of reading back data from here as well, but I haven't studied the circuit to that extent. But it should be both I and O on this connector. The only thing left really here is to take a look at the video circuit up here. The modulator is sitting on the power supply board, which is okay, I guess, because they wouldn't have enough space on the main board. So that is a design choice. But anyway, we have 2 or 3 ICs which are interesting up here, apart from the 6847 video generator chip. The first one is for the middle connector here, which is for the tape recorder. What we have here is an op amp. And we have a relay here for controlling the motor to the tape recorder, which is okay and common in some computers. Apart from that, we have a little Motorola 4053, and that's an analog switch, so they could switch in different signals here to the tape recorder. The other chip, which is important here, is the LM1889, which is this little chip here. And basically what that does is taking the red, green and blue signals from this chip and converting them to a PAL signal. And of course PAL is for the analog TV. And that goes through the modulator up here. Also we can see the crystal here, which is 4.4336 megahertz, which is the standard PAL subcarrier frequency. So yeah, that's it really for the Dragon computer. Let's put it back together and try and hook it up to my TV and see how that works. Okay, so here we have it, and let's switch it on. Okay, now as you can see, the basic is a Microsoft basic from 1982. So not to steal Dragon Data's thunder, but the hardware is something that was designed by Motorola, and the software was designed by Microsoft. So all Dragon Data really had to do was to integrate everything. But nevertheless, it's a really nice computer, and the design choices that they made, I think, were really great. The enclosure is really, really nice and solid and sturdy, and the keyboard is good too. And of course the Microsoft Basic was king in those days. So before I go, let's just do the little print. Hello world. And let's run that. And hello world. So yeah, that's it for this video. Thank you for watching, and see you again soon.